Hello, this is David Bates, and this is Team 6's second and final video progress report. In looking for a meaningful experiment, not only for the RAS, but for future space operations and colonization, we have settled on documenting and analyzing the behavior of honeybees during the different phases of the rocket's flight. As excellent pollinators, they will be indispensable for the colonization of other worlds. With that in mind, I am working with a local apiary to develop the pod that will give our bees the best chance of survival on the pad prior to launch and during flight, while also providing us with an experiment area to view with the RAS. Now I would like to introduce Logan Sisca.
All right, thank you, David. So with our bees in the NanoLab experiment box, we need a way to actually measure their flight throughout the various phases of the rocket launch. Because what we want to study is how the bee's behavior changes as the rocket goes into space and encounters a zero-gravity environment. So to that end, we've developed several sensor options in order to convert the light in the experiment box to sound, and that light will be modulated by the flapping of the bee's wings. So one of the sensors that's currently in our trade space for the experiment is a phototransistor that I have here, and this phototransistor will be measuring the light emitted from an LED on the other side of the experiment box. And with the bees flying between the LED and the phototransistor, they will again modulate that light and will detect a change in the voltage level emitted from the phototransistor and convert that voltage signal into sound. Now we've conducted several experiments with a simulated bee. We did that by taking a Dremel tool and attaching Scotch tape to the bit of the Dremel. Then we spun up the Dremel at 200 to 500 hertz and then converted the voltage signal into sound. We have very promising results from those experiments, and we'll show you some FFTs and waveforms from those experiments now. And going forward, we just want to really kind of pursue the capabilities of this sensor and further develop the electrical hardware that will be in the NanoLab. This includes the printed circuit board that will contain the ICs that talk to the spacecraft itself. So we'll be receiving telemetry over a USB connection from the rocket and be storing that telemetry on board our personal printed circuit board. And the PCB will also be interfacing with the phototransistors and LEDs that I mentioned. Now, in addition to the phototransistor, we have several other options for sensors that are currently in our trade space. And we're evaluating all of those for both for capabilities and cost and power budget and sensitivity. And I'll turn it over to Roland so he can discuss his sensor that he currently is studying from the trade space. Roland?
Thank you, Logan. My name is Roland Lizana, and as Logan mentioned, I also have looked into the sensor to be used for the RAS. I've done several bench experiments with the solar panel. We are kind of leaning more towards the phototransistor because we can get more useful data from it. In addition to doing testing with the sensors, I'm also responsible for the mechanical design. I have designed several prototypes, but we've settled on one for the initial presentation in mid-January. So I'm currently trying to get that prototype built and shipped to Logan and David for doing experiments. I'll now turn it over to Bryan Trinidad.
Thank you, Roland. So by the end of December, we are aiming to have proof of concept. And in January, we are hoping to finalize the build of our experiment to meet Blue Origin's deadlines. We're hoping to conclude all of our efforts with a successful flight aboard Blue Origin's New Shepard suborbital rocket in the fall of 2018. So wish us luck, and we'll see you all next semester. Thank you for listening.